Thank you. Good afternoon, everybody. First, I have to start with my apologies because somehow happened that I didn't realize that we should prepare our presentations in English. So I am probably only one who didn't capture it, but that's sometimes happened. So I excuse specifically my apologies to our foreign colleague that you will see some Czech letters, Czech expressions, and but if you will be interested, I can translate it everything for you. Okay, so what our department is a department of geoinformatics specifically, and it's seated in the Faculty of Natural Science on Charles University here in Prague. What we do is very similar what we just have heard from our colleague from Brno. It means that we are processing data. We are partially also collecting data, but mainly we are processing data. And what type of data? It's because what I am talking specifically about is remote sensing as well. So as you can see, this is basically description what our people in our department, my colleagues, are able to offer to anybody else who would be interested in such kind of output. And we are ready more or less to discuss more any type of cooperation. So if we are talking about the methodology of remote sensing, it means that we are in fact trying to provide some kind of information. But information is very wide expression. Of course, everybody is trying to get some kind of information. So what we are talking about, it's quite wide broad. As you see, this is all type of properties of something which is on the primary, but not only, not exclusively, on the Earth's surface. On the Earth's surface, under the surface, but also in the atmosphere. The type of properties can be very various. It's physical, chemical, but also biological type of information. But what is important is that there is one additional element of information, and this is about location. So such type of data we call the spatial type of data, because we are also able to provide information not only what is it, what type of properties it has, but where it is located as well. And because the data which I'm going to talk to a little bit later about the type of data we can get during the time, it means that we can also follow the changes of these type of properties. So we are talking about the changes both in the properties, but both in the locations. So both type of changes. What type of data we use? Of course, because it's remote sensing, so there are data which are in fact presented as a data, as a measurement of the amount of electromagnetic energy. So this type of electromagnetic energy we try to get from outside. We are not collecting data independently. And they are different type in the structure. So either are isolated measurements in the form of individual points, or it's in continuous, spatially continuous manner, which creates line curves, or images, pictures in 2D, or even in 3D, if we are able to also distinguish different height above the Earth's surface. And because the measurement of electromagnetic energy can be done in the format of the electromagnetic waves, and waves they have a different frequency. We also have what to do, and we process data of different type of frequency or wavelength, if you wish. So mainly this is an optical type of electromagnetic spectra, but also from the longer wavelengths from radio part of the spectra as well. And what is important is, and this is in fact the source of in type of input in our processing methodologies, is that this data are measured simultaneously in different wavelengths. So that's why we called about such type of data as a multispectral hyperspectra, or even spectroscopic in the term that are quasi-continuous in the terms of wavelength. And also different type of sources of these electromagnetic waves, primarily natural one, but also artificial as a radar type of wavelengths or laser, depending on the wavelength. And because I was mentioning that the type of the data can be in different dimension, I mean spatial dimension. So if we are talking about two-dimensional type of data or type of dimensional data, it means that the radiometer as a main instrument collecting the data needs to move to create such a file which would cover some area on the Earth. So different type of carriers, starting from the low-flying drones or UAVs, airborne and satellite data or planetary data. So this is in fact quite general, but it's also typical what type of information we are trying to provide. So now I will follow very briefly, because it's, of course, as you can see, it can have a lot of applications, different type. So I am just selected some of possibilities, and I will go quickly through them. But this is the main message, what type of activity we are doing and what type of output also we can provide. About that, it's so we are somewhere in the chain from the collecting data to provide information. We are not user of that information, so it means that we provide information for some other use, either scientific use or operational use or decision making. So that's how you can see these type of outputs. These mostly they are 2D type of data and outputs. It means information about the surface of the Earth. Map is classical type how to present it. You can see that if we use a map, this is qualitative type of information. It's not quantitative, it's qualitative, because there are different categories of different kind of classes, for example. So this is one type of output. The other methodology is that we can provide information which is, it doesn't mean that they are directly derived from the electromagnetic energy, but it's derived from other implications. So for example, here, this is as an output is a map about the possible risk of getting illness, but it doesn't mean that we can get directly from satellite data information about the risk of illness, but we can derive it based, in this case, on type of vegetation and other environmental data which came in. Time is another aspect. I talk about that if we have a possibility to also to make measurement in different time, that the change itself is sometimes useful type of and wanted type of information. For example, here there is thanks to satellite data from already several decades. In this case, it was through the period of 30 years. So during the period of 30 years, it's possible to get information about the changes, specifically here in the forests, in the part of the Czech Republic. And during that time, it's possible to follow the type of changes, not only deforestation or afforestation, depending how we want to see it, but also what's going between them, because sometimes the changes are not straightforward, but go through the periods of different type of changes between different time. If we use a spectrometric data, then of course it's possible to use it also in the traditionally used spectrometer or spectroscopic type of analysis of data. And here, as output, it's again the picture. You can see on the left side that this is how it would look for an eye. And the white spots on the left picture, they are non-vegetated types of areas. They are some rocks. And interest was, or is, to quantify what type of rocks it can be, and here is spectrometry analysis, which would take in the place. Last two examples are about the different type of wavelengths. So this is a different type of sources of electromagnetic waves. This is from radar, and radar plus also the spatial type, size, and shape of the specific object can be the feature to detect here, for example, avalanche on the snow. And the last one is a laser. So laser, again, in this type, it's about the pointing type of sources, and this pointing type of data, and this can be also used for distinguishing, in this case, for example, vegetation from rocks. So as you see, it's really a wide spectrum of possible things, and I would finish with this one because in the last 2-3 years, we also expanded this type of approach to processing of the planetary data. This is specifically moon. For laser data, which was collected by American satellites, we created the elevation model of the lunar surface. And we also try to get some data ourselves, and for that we use drones. So we have a nice system for obtaining the optical data using this type of technique, elevation technique. So that's all. Thank you for your attention.